Welcome to this explainer. Look, today we're going on a job site journey through what is, without a doubt, one of the most vital processes in the electrical trade: isolation and lockout procedures. Think of this as a high-stakes toolbox talk. The procedures we're going to cover today, which are drawn straight from the Queensland government's official guidelines, well, they aren't just bureaucratic red tape. They are the exact step-by-step methods designed to make absolutely sure you go home to your family at the end of the day. So here's our roadmap for the day. First, we'll cover the stakes of electrical work. Then, preparing for safe isolation, the actual isolation process, testing for de-energization, securing the site with locks and tags, and finally, restoring power safely.
Section 1. The stakes of electrical work.
The guidelines laid out pretty bluntly. Working on or near energized electrical equipment without proper isolation, it carries absolutely severe risks. We're talking electric shock, devastating arc flashes, severe burns, loss of mobility, amputation, and yes, death. A lot of totally preventable incidents happen when equipment was supposed to be de-energized, but was somehow inadvertently switched back on. This isn't just theory, guys. These are the very real physical consequences that demand immediate respect before you even unzip your tool bag. And you know what makes this even crazier today is that modern job sites are way more complex and dangerous than they were in the past. It's not just a single feed from the street anymore. As the guidelines point out, we've got alternate supplies everywhere: solar panels, battery energy storage systems, backup generators, UPS systems. And all of these can backfeed energy right into your installation. Think about it. If you remove the multiple Earth's neutral, the MEN connection, without all these alternate supplies fully isolated, you can create a literal lethal potential between the neutral and Earth conductors. You have to account for every single energy source.
All right. Section 2. Preparing for safe isolation.
Listen, preparation is everything here. Step 1 is positively identifying the specific equipment you're working on, plus anything nearby that might present a risk. Step 2, spotting all the energy sources. And honestly, here's a curveball. It's not just electricity. You've got to look out for non-electrical energy too. Is there hydraulic or pneumatic pressure and a tank nearby? Is there mechanical energy, like the massive tension of a spring? What about stored heat in gear that's been running all day? Step 3 is finding all the actual isolation points for these hazards. And step 4 is figuring out if any backup supplies, like emergency lighting or medical oxygen, need to be kept running while you work.
Section 3. The isolation process.
So the crucial point here is getting the disconnection right. You must isolate the equipment from all sources of supply. And there is an exact, highly recommended, and legally mandated sequence for this. First, you disconnect all active conductors. Next, you disconnect the neutral conductors. Finally, and this is so important, the earth conductors must be disconnected last. Following this specific sequence, make sure your safety systems remain completely intact for as long as possible while you neutralize the threat. While you're isolating, you need to watch out for a few massive red flags highlighted in the safety guide. First off, never, ever use control circuits or functional switches, like your standard light switches, as isolators. They are simply not rated for it. Second, when dealing with solar, if you pull an MC4 connector while current is still flowing, you are going to draw a massive, dangerous arc. You always prove zero current first. And third, if you disconnect current transformers from their low impedance circuit, they can produce a lethal high voltage. Always install shorting blocks, links, or bridges whenever a CT circuit is interrupted.
Which brings us to Section 4. Testing for de-energization.
Keep in mind that under electrical safety regulations, the act of testing itself is legally classified as energized electrical work, so it requires your absolute 100% focus. The golden rule: all conductors must be treated as live until proven dead. You can never just assume a flipped breaker actually worked. Plus, please do not rely on a proximity tester as your primary tool, because they literally do not detect DC voltage. You need a properly rated contact test instrument, like a high-quality multimeter that's fully capable of withstanding fault currents. Now, to make absolutely sure your test instrument isn't giving you a false negative, say you've got a blown internal fuse or the battery just died, you have to follow the 3-part testing rule. It's non-negotiable. Step 1. Test your instrument on a known voltage source to make sure it actually works. Step 2. Test between all supply conductors and between those conductors and a known earth to confirm the circuit is totally de-energized. Step 3. Retest your instrument on that known voltage source. If your meter doesn't read the known source on Step 3, your zero reading in Step 2 means absolutely nothing. Never trust your life to an untested meter.
Okay, Section 5. Securing with locks and tags.
Whenever you do not have sole, effective control of the isolation device at all times, meaning you can't physically see it or someone else could easily access it, you absolutely must fit that device with a physical locking mechanism and a warning tag. This is exactly what stops someone from accidentally returning power while you're literally elbow deep in a board. And if a whole team is working, every single person must attach their own personal lock. On any professional job site, you've got to recognize a crucial distinction: the difference between a danger tag and an out-of-service tag. It really just comes down to what we are trying to protect. Danger tags, which are always red, black, and white, protect human life. Out-of-service tags, which are yellow and black, these simply protect broken or unsafe equipment. To put a really fine point on it, an out-of-service tag can be removed by any competent person once they have repaired the defect. But a danger tag? That is sacred. It can only ever be removed by the person whose actual name and signature are written right there on it. It is a personal, physical guarantee that returning power will not endanger their life. And finally, Section 6, restoring power or pausing work. Restoring power is not just a matter of ripping off your lock and throwing the breaker. You need to treat this like a pilot's pre-flight checklist. These steps are completely non-negotiable. First, you must notify all affected personnel that the power is about to come back on. Then, you do a careful visual inspection. Are all your tools accounted for? Is all surplus material and garbage removed? Next, double-check that all conductors have been appropriately terminated and your mandatory testing is completely finished. Finally, make absolutely sure every single guard, cover, and barrier is fully reinstalled. But hey, what if you aren't done? If you're leaving unfinished work, you have to do it professionally so you don't leave a deadly booby trap for the morning shift, or worse, an unsuspecting civilian. The site has to be left in a perfectly safe state. That means terminating and fully enclosing any exposed wires. You must tag and physically tape off the electrical equipment and the whole surrounding area. Ensure the status of the switchboard is clearly labeled. And critically, you have to hand over adequate information to the workers who will be taking over so they know exactly what they are walking into. So I want to wrap up this explainer with a provocative question to take with you to your very next job site. If you don't control the point of isolation, who does? You can never just assume someone else secured the power for you. Taking personal responsibility for these isolation, testing, and lockout procedures is literally the only way to guarantee you make it home safely. Thanks for hanging out with me today, and please stay safe out there.